Hey YouTube, Colorful Codes here. Long time no see, but today I have a very special algorithm or data structure, I don't know, one of them, to show you guys. It's like super popular. It's the number of islands algorithm. I'm so happy, like I finally revisited it, and then when I was studying it I was like, oh wow, like this is amazing, you know. I'm going to start off with a visualization on the board showing you what the question is asking for exactly, and if you have like any more inquiries, ask me in the comments or check the blog post, because the blog is going to have like the depth first search version and the breadth first search version like broken down. Yeah, and I think that's it. Oh yeah, so like visualizations in the description box and on the blog post. Okay, so stay tuned. Alright, so right here, this is the island, my attempt at the island, and then this is the representation of the island in grid form, graph form, matrix form, whatever you want to call it. So as you can see, the ones are going to be the islands. If you've done the LeetCode question before, the ones are the islands. The zero is the zero is the water. So this right here is the island. This is the island. This is the island. This is the island. This is the island. And this is the island. So how the problem goes is that everything that is to the, like for example, anything that's to the left, down, up, to the side, that's an island. Nothing diagonal is an island. So this is an island because this is below this and this is here. So we're doing the depth first search version of this, and these are all islands. They're surrounded by water. I want to show you the difference between a breadth first and a depth first search, like right now. So normally, if we were on this problem, what a breadth first search would do is that it would look at what's above, and it would see, oh, it's a zero, whatever. It would look to the left, and it'd be like, okay, that's a zero, whatever, and then it can't look there. And then it would look below it, and it would see, oh, okay, so this is a 1, check, and then like it would start over. But like that first search, what it does is that it would see a 1, and then it would move to that 1, and then it wouldn't just stop. It would move to that 1, and then it would check like all around, and if it sees another 1 next to it, it would move to that 1. And then hypothetically, there was a 1 here, or wherever, it would keep on like for example, if this was a 1, it wouldn't stop anywhere. Like even if this was a 1, like it would look up, and then it would continue there, and then it would check up and down, and then finally when it checks everything, it would come back, and then it would check again. I hope I explained that correctly. This is a recursive algorithm, so this is not an easy task at all. So I also included a link to recursion Python, like so that you can learn about it or whatever. So yeah, that's basically what we're going to do. We're going to do a depth first search. Alright, let's go. Alright, so I'm going to start with the first algorithm. It's not going to be the depth first search. It's just going to be our main algorithm first, okay? So here we have our algorithm, islands, and what it's going to do is that it's going to take a graph, a grid, whatever. We're going to call it towards the end. So I don't know if you guys can see that, but there goes our graph right there. So this is what it's going to hold. It's going to hold that graph. Okay, and we're going to start with our first edge case in case we don't get a graph, like it's empty. So we're going to say if not graph, return 0. So there's no islands. Okay, and then what we're going to do is that we're going to do a nested for loop. because that's normally what we do when we're trying to get the rows and the columns in a 2D array. Okay, so row will equal the length of the graph, and the column will equal the length of the graph, but the first length of the row. So, as you can see right here, so this is what row is, all right? Row is 1, 2, 3, 4, okay? Index 0, index 1, 2, and 3. These are rows, okay? Let me put a comma. And what the column is, this is a column. So if you see here, we have the length of graph 0. So as you can see, this will be a column, 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 this will be a column. So that's basically 1, 2, 3, 4, 5. There's 5 items in it, so we know there's going to be 5 columns, if that makes sense. So it's just counting the first item in the graph, 1, 2, 3, 4, 5. So it already knows that there's going to be 5 columns. Okay, hopefully it's understandable. We also need to set the count, so how we're going to count the number of islands we have. So we're going to set our count equal to 0. I wish I had a bigger whiteboard. Alright, so now we're going to do our main for loop. So our first for loop, for I in range, and then it's going to be the range of the row. So I is going to start at 0, that's what range starts at. And then we're going to have an inner loop that will get the column for j in range col. This may seem confusing because I know nested for loops for me, anytime a grid question was confusing at first, but hopefully I will explain it correctly in one moment. And then I'm going to do an if statement. So I'm going to say if graph I, so this is the first row, or yeah, it's going to start at the first row regardless, I and j, which is the first item, equals 1, the number 1, we're going to call the recursive function, which is the second function that we're going to do. It's going to call DFS, and that first circuit is going to have the graph. Can you see that? And it's going to have the row and the column and I and j. We're going to pass everything into it, all the arguments. Row, col, I, j. Okay. And then it's going to, right after that, we're going to add the count. Plus equals 1. So I'm going to explain this right now. Okay, so what this first for loop is doing is that it's iterating 1, 2, 3, 4. Okay, the length of the row is 4, the indexes 0, 1, 2, 3, and that 3. Okay, so it's grabbing, it's going to start at the first index, 0. Okay, and then at the first index, it's going to within the first index, j is also going to start. So here we're at the first, and so is j. So inner for loops are going to continue to keep on incrementing. While we're at the first for loop, which is 0, we're going to have j, and j is going to also be 0, 0. So it will be like 0, 0. So until j reaches the end of the list, it's gonna, I is always going to be 0. So it's going to start off, it's going to say, the graph is going to be like graph 0, okay, this first list, and then it's also going to be 0. So it's going to be 1, the first item, and it's going to check, oh, is the graph, does it equal 1? And if it does, which it does right here, it's going to call the next function. And I'm going to show you what the next function is going to do, but yeah, that's how it's going to keep on going. And then once it does that, it's going to, hypothetically, if this weren't ones, let me show you what happened. If these were 0, I would still be 0, and then j would be 1, and then j would be 2, and then j would be 3, and then j would be 4, if that makes sense. And then finally I would increment one more time, and then I would finally be 1, and j would be 0, because it starts over, and it would continue going, like j would be 0, j would be 1, 2, 3, and then 4, and then I would increment again, and then I would be 2, and then j would start at 0. So it'd be like 2, 0, 2, 1, 2, 3, 2, 4, and then it would continue again. Alright, so now we're going to do the depth first search, the most important part of the algorithm that we've all been waiting for. So, what we called before was that when we found there was a 1, okay, we called the depth first search function. Depth first search. And we called it with the graph. And we called it with the row, the column. And now we're going to create new variable names because we don't want to get confused. We had I, j before. So x is going to be I and y is going to be j. So we can say x and y. So when the algorithm first enters, when we first call the depth first search, it's going to check again to see if where we are right now, if x and y or I and j, if it equals 0. And then after that, I'm just going to keep on checking it. So it doesn't really matter for the first time because we already know that it doesn't equal 0. But when it continues calling within itself over and over and over, you're going to see, then we're going to see the point of why this is here. X and y. So as you know, this is the row. We are in the row, and y. And these are both 0. So this is where we are right now. We are here, okay? So 0 and 0, okay? And we're checking if it equals 0, which it doesn't. So, and if it does, then we return. So with breadth first search and depth first search, normally when we've already visited a node, we put it in another list or stack or queue or whatever you want to call it as visited. But in this case, we can just 0 it out. So here, before it was 1, and then I changed it from 1, and I just turned it into a 0. So that we won't keep on counting every time because this is depth first search. So it's going to keep on checking. Oh, this is a 1, so it would keep on incrementing, and we don't want to do that. We'll just turn it into a 0 because once it's exited the main loop, once it's exited the main recursive function, it's going to increment. So we already know that it will increment at least once. So we know that these are going to be attached, so we don't want to keep on, adding the count. So this is where we turn the 1s to 0. So we're going to set graph x, y, and we're going to set it to 0. If it was already 0, it would have returned and exited. So our first if statement is going to check to see if x equals 0, because 0 would mean that it's the first row. So in this case, we are on the first row. And this is important because if we're on the first row, we can't check what's above. Like it would be a negative number, we'll be out. But hypothetically, if we were on the second row, like if if x was 1, the second index, then we could look above and see, you know? So for example, I'm going to show you right now. If x does not equal 0, so if x is not the first row, we can look above. We'll call the recursive, we'll call this function within itself. So we'll call the graph, the row, the column, and then we'll call x minus 1. So if we were on this row, that means x would be 1. So that we will be able to look at the row ahead of it. And then we will just be in the same place with y. Okay? But in this case, this doesn't apply to us. We'll also be checking if x isn't the last row, because if we're the last row, we can't look below us either. So we're going to say if x does not equal row minus 1. So you remember the length of row is 4, and right now x is 0. So 4 minus 1 would be 3, and right now x is 0. So we're not the last row, you know? So this would apply to us. So what would happen here for the depth first search is that it would go again. So I'm going to show you right now. Row, and right here we do the column, and then we're going to do x plus 1. So if we're here right now, what x is doing, this is where we are right now. X is looking down here, because you know y is also 0. This is y right now. Okay? So right now, x is 1 and y is 0. So we're right here. So x is looking down here. So it's going to call itself again, and it's going to check to see if 1, 0 equals 0. And so because it does, it's going to return and it's going to come back down here. And what we're going to do next is that we're going to check the right now. So now that this is finished, now that we know that that's already 0, we don't really care about it. So we're back to square 1. So now we're going to check right. But as you can see, there is no right. So here's what's going to happen. We're going to have to check to see if y does not equal 0, because this is where y is right now. 0, 1, 2, 3, 4. Okay. Right now y is 0. It's the first column, and we can't look before the first column. It doesn't make any sense. So if we are on this column at all, we're just going to have to skip it. But I'm going to write the code right now. If y does not equal 0, if it's not the first column, then we're going to do another recursive function. We're going to check to the left. Okay? So yes, we're going to check the graph, row, we're going to add in column, x. So yeah, so right now this is y. There's nothing there. So hypothetically, if y was here, we would be able to look here, but we can't. So yeah, we're just going to skip that. So I ran out of space on that board, but these are the last 2 lines of the code. So what this is going to check is it's going to check to see if we are on the last column. Notice that we have 5 columns. We have 5 columns, and so we're going to see if y does not equal 4, because 5 minus 4, we would know that we're on the last column, and we can't look to the right of the last column. So in this case, we're on the first column, so this will work for us. So we're going to call that first search again, and we're going to check to see if the right. So y plus 1 would be the right of the function. Yeah, and then it's just going to continue going. So I'm going to try to bring you to the board. So in this case, we are checking to the right of us, okay? And here we see that it equals 1. So now that we checked, we called the function again, we end up here. It's checking to see if 0 and y plus 1 equals 0, which it doesn't. So it can't return. So what it does is that it turns the value into 0. Okay, and then it goes through this entire process again where it sees if, now that we're here, this is where we are right now, it's going to check, is x equal to 0, which it still is because we're on the first row. So we're going to skip that, and it's going to check, is x equal to the last row, which it's not. We can call the function again, and it will check to see if it equals 0, which right now you can see it doesn't. So it won't be able to return. It will zero it out, and now this is 0. So now that this has been zeroed out, it will move here and it will check above it, it will check to the left of it, to the right of it, to the bottom of it, and then it would return back here and it would check once again this side, that side. It can't look above it, and it will look below it, and then it would return back here, and we would be back at the main function, which would be a number of islands. And so we see that we zeroed out everything and our count is at 3. 3 islands is what we found. So we just return, and that's basically it. The blog post will be a lot better. Yeah, but this is a problem where you really have to like sit down and break it down like step by step by step, and use a visualizer. Like Python Tutor is really good. I say that in like all my posts and videos. But yeah, so we made it. So yeah, so definitely check the description box for the blog post so that you can really understand it. Yeah, this is a very popular question. You can do it with breadth first search, depth first search. It doesn't really matter. So let me know if you have any questions, and best of luck. I'm going to do another algorithm next week. I'm going to do the rotated matrix algorithm. So hopefully you guys enjoyed this and understood it, because it was a lot harder explaining it than I thought it would be. Okay, take care, bye.